Okay, so today we're going to go over why data. So what do we do with data? What is it? How do we kind of structure this giant theory of what we call, data science, data analytics, data engineering, machine learning? There's all these names, and how do we, what lives under that bucket and that umbrella? So I won't go through the agenda, but what I will do is later on I will be making these available in some way. And so I like to have all this laid out. We did intros. We won't do a warm up just to keep time. But to start off, let's just talk for a minute about why data. Data is this really massive idea that in theory is very overwhelming, but ultimately what it is us living our daily lives in a measured way and understanding the things that are happening to us through root scientific theory. And so what data allows us to do is to make decisions. It allows us to be, more factual, which seems like a counterintuitive statement. How do you be more factual? But if you don't have the information available to you, you can have something that's believed to be a fact, the earth is flat, until you have the information that in fact the earth is curved, and then we learn that the earth is round and the earth is flat is no longer a fact. So having that data available to us in a way that is tangible and understandable is hugely impactful, both in business, and in our personal lives, in the public sector, particularly in the public sector when it comes to creating financial margins or impacting people's daily lives through the decisions that are made by stakeholders, by people in government or people in nonprofit institutions. Data can change people's lives. It can impact where a program is outlined, is determined, and so we use data for all of those reasons and so many more. So when it comes to using data, we have to consider a few different things. And I mentioned this in the last session, but with each of these topics of discussion, we will be having a discussion session every few training sessions. So with this lecture and next week's lecture, there will be 1 week of discussion. And so we'll bring up these questions again. But when we think about data and why we use data, one thing I like to think about is the not necessarily adversarial, but in fact partnered qualities of qualitative and quantitative data. Often people think of these as going against one another, but really these are two different tools in the toolbox that we have to make decisions and to drive the way that we do things. One thing that we use data for and why we use data is to understand our inherent biases within ourselves. Particularly within the last 2 or 3 years, we've seen equity initiatives growing within organizations. And those have run into these issues of inherent biases that people were completely blind to without the data that was there to show them, hey, you may think that you're hiring in an equitable way, but in fact, because of inherent biases of naming bias or other resume bias, you are actually creating inequitable hiring practices. And so we can use data to combat that as well. And then ultimately, one thing that I like to drive home is the use of the null hypothesis method. So this is a scientific method that requires us to both ask a question with a theory and the statement that that theory is wrong. And by doing that, it goes into any project without the assumption of what the outcome of that project will be. So as we go into a data analysis project, or an engineering project or machine learning, there is no end goal that we've decided on. We are ultimately allowing the data to drive that conclusion, and that in and of itself can erode away our inherent biases. So these discussion questions, feel free to read through them, and just keep in mind as we go through the lecture, and then as we come to the discussion session in a couple of weeks, we will go through these more. So right now I am going to go through a lot of information about the different areas of data. So data is what we call overall a data governance. And this really encompasses all aspects of data quality, data collection, data engineering, modeling. This is also lately being called the data fabric. So how do we weave all the pieces of data into this larger web or larger fabric of all of the pieces of data? So data governance or data fabric is this holistic structure and full implementation. We'll talk about this more, but it combines technology, hardware, and people. So it is not just your BI tool. It is not just you, the person who is a data analyst. It is all of these aspects together. And each piece of this is key in building out a comprehensive data solution. So without one of these, you are missing something truly integral in building out that data fabric. So I will quickly go through these areas. Again, I'll make these slides available, so the definitions will be available to you. And we're going to go over these. I believe we're only going through half of this today, and we'll go through half of this next week. So architecture, the design of the physical and virtual infrastructure. Modeling is the manipulation of data using algorithms. Storage and operation, management of physical and virtual infrastructure. Security, processes, policies, and technology. Keep in mind, security, and we'll get into this, but security is not only technological security. It's not only about setting up firewalls and ensuring, secure access keys. It is also physical people, and how do you train people on secure practices? Documentation and content. I say constantly that documentation saves lives. It does, particularly the time in my life that I have to spend explaining to 17 different people the way to do something versus writing it down and being able to give that piece of documentation to someone else. Or, the time I have to spend trying to figure out someone else's code that isn't documented. All of these great time saves through documentation. Data warehousing and BI, so the restructuring and analysis of data for decision making. Integration management, so how do we bring all of these different data sources together? Quality, which 95, 99% of data is data cleaning. And as far as quality goes, you get bad data in, you're going to get bad decisions out. So the quality is really important. And then references and metadata, and these are ancillary aspects of data that are extremely important in driving the story of the data that you're trying to tell. So we're going to get a little bit deeper into some of these, and for the first I've built out some examples of what this looks like. So for data architecture, you're really thinking about not necessarily the specific tools that you're going to be using to structure and manipulate your data, but instead the design, component, strategy, and theory. So what does that 30,000 foot view look like? And so what we can do for an example of this is take the example of building out a data warehouse. So a data warehouse, you know, at the very basic level is taking raw data, putting it into a warehouse, and within that warehouse, making it accessible for analysis or for the external organizations that you want to provide your data to. Next, we talk about the architecture middle layer. So again, this is design, component, strategy, and theory. If we were at the 30,000 level before, this is the 20,000 foot level. Here we have our data warehouse again, but instead of just having the raw data sources and the outputs, we have the specific raw data sources. So backup, internal application hosting, centralized GIS capabilities, all of these pieces of the data fabric that can then be integrated into a data warehouse. Or we can push out to third parties, and we can have an open data portal that's available to the public or available to our internal employees. And so what this does is start to really build out the design of what your goals of a data fabric is. And so this is what the architecture gets at, is what are your overall goals and how are you going to get there at a very base level. And then finally, for architecture, we won't get too much into this, but I just wanted to show you then what that 10,000 foot view would look like. So once you get down to the 10,000 foot view of your design, you get more specific. You talk about whether you want multiple environments. For this example, I only brought two in. So we have a production environment and we have a test environment, but within your architecture and within your fact finding for your architecture, you may decide that you need a development environment as well, or you need an environment that is not just production, but truly client production. So you need test, you need internal production, and then you need a client-facing production. So as you continue to build out your design, you can understand more how you want that architecture laid out. So that was a lot of content in a very short period of time. Does anyone have any questions about this first piece before we move on? Okay, great. Okay, data modeling. So there's a variety of different types of data modeling. The first I want to talk about is infrastructure mapping. And so what this looks like, excuse me, is similar to the architecture mapping, but more specifically at the point at which the database has been built out. So we know all of the tables, all of the variables within a database. And this infrastructure mapping, or sometimes called data cataloging, shows the connections between different tables, between different variables, how they relate to one another, and how they're updated. So that type of modeling allows you to design out and better understand how to use your database. Schema development is a type of modeling that is the technical and physical layout of tables within a data resource. So what that is like, how do you actually physically build out your variables, your columns? How are you bringing in your rows? What do they look like? And what this does is creates a logical structure for your database, and ultimately really standardized modeling and really designed modeling at the outset of creating a database is key to scalability of that database. It'll make things easier a long way down the road if you do things properly and really thought out initially. Next, we have storage and operations of data. So with this, we want to talk about administration. So administration of data is all around the capabilities to understand your users, to kind of, like I say here, user management, setup of additional data software and integrations, maintaining licenses, identifying best practices in implementation, and building out ETL, ELT, or data factory solutions. So what this is all the back-end management. If you think of administration within a physical office, that person is, coordinating between departments. They are making sure that, keys are handed out properly. They're making sure that that everything has been up to date. So like licenses and everything has stayed up to date. So so that type of administration is also key in data storage and operation. As far as storage and operations goes, it's really important to, again, have this technical theory and use it to create a comprehensive layout before building out your storage and your operations. What this means is the larger architecture should be designed before implementation, and having all of those designed out beforehand will allow you to create ease of access moving forward. And finally, we have resource management. And what that means is the identification and management of all of your resources across your data fabric. So what size your servers are, how do you deploy your databases, who has access. All of these things are really important as you deploy your storage and operations for your data systems. I'm going to pause here for a moment because I really have to cough. So please, if you have any questions, ask them now.
I had one in case anybody knows the answer. On this slide under administration, in that first paragraph where it says build out ETL or ELT, I don't know what that stands for.
Yes, I apologize. I forgot to.
Oh, that's okay.
ELT and ETL mean extract, transform, and load, or extract, load, and transform.
Okay.
And the difference is really at the it is key in your design of a data warehouse or database or data fabric, because transforming data before you load means that you're probably doing less processing on your resources. You're not spending as much money in hosting, all of these cost-saving things, but you're also not going to have access to all of the raw data directly in your database. Does that make sense?
It does. Thank you.
Of course. Okay, so next we're going to talk about resource management analytics, what this is. And so what you're seeing here is an example of resource management analytics. This is identifying your data resources, so servers, SQL pools, databases, key vaults, which is where you can store all of your passwords and secrets and keys. What else? Different workspaces, cloud access. All of these require compute. And so even if you're in the cloud, those resources cost compute. And by maintaining and managing your resources, you can save money, but you can also identify and do code review. And the way that you can do that is you can run a query, and then you can use your resource management to go and see what your compute looks like for that query. You can see if you're running high compute. And are there ways that you can rein in that query? Are you pulling data you don't need? Are you doing unnecessary joins or sloppy joins? Can you reassess how you're building that SQL query to decrease the cost, especially on repeatable queries down the line? So if you have a query that's going to run every single day, you want to make sure that it's as streamlined as possible so that every single day you're not wasting, maybe 50 cents a day, but if you run it day after day after day, that adds up. I think if you run that query, I have queries that run once a minute. If you are wasting 50 cents once a minute, that really adds up really quickly. So you want to streamline that, and you can manage that through your resource management analytics. These are really readily available for cloud systems. They are less readily available for on-premise systems, but can be purchased through third parties usually. Next, we're going to talk a little bit about security. Data has multiple types of security that you need to focus on. So first, we have personally identifiable information. We as analysts and engineers and anyone who interacts with data, we have access to extremely personal data. Often, people's addresses. That's not super personal, or it's very personal, but it's not super high risk. It's easy and public often to get someone's address. But then we often have access to people's phone numbers, which there are not phone books anymore. Usually access to someone's mobile phone number is only available through, getting their phone number from them, or they posted it online. Some people who do data analytics have access to people's social security numbers. Think of how dangerous that is if the data gets out. So personally identifiable information has the potential to identify a specific person, either outright or through descriptive data points. We break these down into low, medium, and high risk, and then you can categorize different data points into these different categories to determine what security on any of those given data sets within your organization look like. And just to be clear, what I mean by either outright or through descriptive data points is by combining data points or data sets, you have the potential to identify individuals. For example, you may have a data set that is aggregated to the gender of the individual at a 300-person organization. That, is great for people who identify as male or female, but for individuals who identify as non-binary individuals or other genders, this may be an issue because they have a smaller population within a population of 300, and therefore that person could say there's only one person who identifies not as female and not as male within an organization. That person is easily identified in a data set that aggregates to gender. So there are other examples like that where you can aggregate to different demographics of individuals, or where there are data sets that connect individuals to their license plates, and therefore you can identify where a person is at a given point because their license plate has been tied to them in a publicly available data set. So these are the types of concerns that you have to consider when bringing up security within data. We also walk a line as data scientists and engineers and all of the different nomenclature that we have of transparency versus security. Especially as of late, so probably within the last 5 years or so, transparency has been really key within the data community. Our goal is not to be knowledge hoarders. We are to be storytellers and those who bring knowledge to the public. Often, this is what drives the open source movement. It's what drives open data portals and hackathons, is the idea of bringing community together for a larger goal through data transparency. However, we also have to keep in mind this data security and understand both legally and within our organizational goals how we can ensure security while providing as much transparency as we possibly can. And so ways that we can do this is through data sharing agreements, NDAs, so non-disclosure agreements, and MOUs, which are memorandums of use, I believe. I use these acronyms so often that sometimes I forget what they mean. So what we can do to kind of combine this transparency and security is developing partners with other organizations and collectives that we do business with, and combine our resources and create true contracts that say, I trust you to keep my data safe. I hope you trust me with keeping your data safe, and therefore we can share and create this bigger thing. Any questions? Okay. Just a couple more slides, I think. So first, documentation and content are key. Documentation truly saves lives. It has saved my butt more times than once. Pieces of documentation that are really key within an organization are the data dictionary. So a data dictionary, which as of late has really evolved into a true data catalog, is the consolidation of all the metrics across a data resource. And I would even expand that to across the data within an organization. So not just an individual resource, but across the entire organization, with definitions, data type, table location, notes on the metric. Sometimes this includes what we call lineage, and lineage is a tracking of the metric. So there are 3 types of, they're not data types, but they are types of data. Because data types are a very specific thing. But there are 3 types of data that we call raw, calculated, and analyzed. So raw data is the data that we've collected. It's not aggregated, nothing has happened to it. There is calculated data that is simple calculations, two variables added together. This times 0.01 to create a percentage. Basic calculations. And then there's analyzed data, and that is data that has gone through a number of different permutations to create a data point that truly tells a story, but is not necessarily very close to the original data point. What lineage does is it traces back any of those calculations, transformations, permutations of that data point to show you how we get from the raw data to that very abstracted data. And so that documentation allows you to track different calculations and algorithms that are used to create that abstracted data point. Documentation and content isn't just necessarily about the data, but it is about creating data literacy within those using the data. So it's ensuring that those who are using the data are well versed in how to use it. That includes trainings and workshops. Any data resource that is being available to anyone should have training documentation associated to it. Whether you're actually going to go through formal trainings, having that available in a digestible format is key to ensuring that the data is actually used in a way that it's supposed to. And then workshops are hands-on and meant to engage with those within the session. So I would say that today's session is a training, but our discussion will be more like a workshop. So workshops are meant to develop use cases, identify gaps in knowledge, break down silos, build data strategy, and answer larger data-related questions. They're meant to engage the organization into the data and create a larger data story that is not just siloed within those who have data in their title. Okay, this is our last category for the evening, I promise. So finally for today, we will talk more about different categories in our next session. But finally for today, we're going to talk about data warehousing and business intelligence. So these are often the sexy, awesome, digestible, in-your-face pieces of data science. Dashboarding and, user sentiment, different things that are very much in the public eye around data. That's where we run into data warehousing and BI. So what this is a consolidation of data. A data warehouse is where you bring all of the information that you actually want to use. You turn your data from a mountain into, not a molehill, hopefully, but into something that you actually want to use. Consider having a whole beach full of sand and then bringing it into a sandbox. You really only want to bring in the sand that you're going to use. And that's what your data warehouse is. This is also key to scalability because it does require an organization to look at that beach full of sand and identify what their goals are for data as an organization and how they can get there in a scalable way. And a scalable way is not to do full analysis on that entire beach of sand. Types of data warehouse schema. We will have a SQL session later on, but data warehouses identify in Star, Snowflake, and Galaxy. Star is one fact table in the center, and off of that fact table are dimension tables that describe that fact table. So if we were to have a table of plants and number of plants planted, what we might have as a dimension table, so that's our fact table. Off of that is a dimension table that's, you know, plant color, and then it might be plant family. And so what that does is it allows you to obfuscate these descriptors of plants while maintaining that fact table of the number of plants planted. Snowflake is similar to star, but instead of the dimension tables only being connected to the fact table, they may be interconnected to other dimension tables. So you start to see the snowflake pattern as opposed to that truly centralized star pattern. And then Galaxy is a combination of these. Galaxy may have more than one fact table associated within a given, we call them cubes or perspective. And these fact tables don't connect to one another, but they do connect to dimension tables that also connect to that other fact table. So they're related, but not distinctly connected. Then when it comes to BI, we have, you know, algorithms, operations, predictive. Kyle, you brought up earlier, natural language processing. That is really exciting. BI, machine learning, auto machine learning, which is a really interesting new trend. And this relies a lot on back-end development support. So a lot of data engineering bulk and then data science development. And then whereas dashboarding and reporting, again, is that data engineering in the back, but not necessarily as robust as the algorithms and operations and predictive, but with a data analyst at the output. And so instead of data scientist, you have a data analyst working on the best way to story tell with that data, as opposed to the best way to build an algorithm with that data. Okay, that is the lecture for today. I know that was a lot of content in, I don't know, 40 minutes maybe. So any questions?
Amanda, I had missed, there were 2 questions in the Q&A, but I'm not like 100% sure how to answer them. I don't know if you can see that like window.
I can try to. Yes. What is a data catalog? A data catalog is a collection of all of the information that, or not all the information, all of the metrics that make up a given database. So if you think of a table as built of columns, a data catalog identifies each of those columns. It has a definition for what that column is. So to go back to our plant example, if the fact table is built up of plant name and number of plants planted, we can say that the data catalog is plant name. This is the name of the species of plant. And then number of plants planted. This is the number of plants that were planted in a single day in this greenhouse. And so you get that very specific information about what is in that table. And that's across the entire database, data warehouse, whatever you're building. I only see one.
Okay, I can read the other ones. One of them was, can you explain data modeling again?
Yes. So data modeling is the creation of almost like process maps of the data that you have built out. So similar to a data catalog, it gives you insight into what the data itself is doing. But what this does is the modeling itself will map the connections between tables. So if you have an ID on one table and that same ID on another table, you'll be able to see it will model a link between the two of them to show you that when building out a SQL query, you can query both of those tables and join on that ID.
And then one of the other ones was if you could provide an example of, I think, source to database using ETL.
Yes. So I will use an example that I've been playing with lately. My older brother is really into day trading and has gotten into a little bit of cryptocurrency trading and stuff. And he is also really hard to shop for. So for his Christmas present, I am determined to make him a dashboard that will bring together all of his delightful stock tips and everything into a single page. So what I'm using for this is an Azure database, and I have found there is an organization that builds data off of NASDAQ. It's called NASDAQ Data Link, and they have an API. So you can use this API that they have built into their website to call directly into a SQL database. And what you can do from there is create a connector directly in Azure, and that will bring all of the data that is available within that website into your system, and then you can schedule updates. So the API call is the extract. The updates are the loading. So you can say, I want to update this every 5 minutes. And so 5 minutes, 5 minutes, 5 minutes, that's your loading. And then once in the database, you can transform that data by doing different manipulations, transformations, etc. Any other questions?
I feel like I'm probably going to have some as I like kind of absorb this and maybe watch the video again and stuff like that. So I'm wondering, related to that, if there's like on the Syracuse.io Slack, is there like a channel for this group or this class or the WIML DS group or something, or
there is not. I can make one. Actually, that is a really great idea.
With each other in between classes and ask questions or share things or whatever.
Yeah, I will.
Especially if we end up working on some group projects, it would be handy. So
yes, I will make sure to build one in, and then I'll put a note in the general channel on the name that I've made so that everyone will know exactly what it's doing. Hands up if you don't know what we're talking about with the Syracuse IO, because then we can talk about that and I can get people access. I can't, but other people know how to do that. Okay, so Syracuse IO is a Slack community within Syracuse that is a community of all of the developers within the area. So so it's well beyond data. It's, a ton of people are really enthusiastic about code, and in the Syracuse area, there are a lot of different meetups, and there is this giant Slack channel of all of us kind of nerding out online together. To access Syracuse IO, there is a website that you go to. It is a Google form that you fill out. Does anyone have the link to that directly? Otherwise, I can find it. But either way, you can look up Syracuse.io online, and that is a Slack channel that you can go to and kind of commiserate with other coders in the area.
I have one additional question. Thank you for answering all the questions and going through this. So earlier you were talking about the data warehouse schemas. You mentioned Star, Snowflake, and Galaxy, and I was just curious about why you selected those three schemas. Do you think they're the most important? Because I typically hear like a physical schema, like a logical layer. I'm trying to understand why those ones were
Oh,
selected and what the differences between
yes.
them.
Yeah, so those schemas are kind of like the build of schemas. So like the design, whereas I believe what I think you're talking about is what we call abstraction layers, or it's either abstraction layers or zones, which are two different things. So abstraction layers are ways in which you can curate the data and determine different things like a physical layer. So, for example, if I used to work for the city of Syracuse, so I will use public sector as that example. To have a physical data layer would be to have a data layer that contains all of the physical infrastructure of the city of Syracuse. So street lamps, water mains, construction, the road layer, all of those different things would be a layer. And then you could have things like human resources layer and policy layer, like what policies have been implemented in the city. So that's what we would call like an abstraction layer. And then the other concept around data is zones. And so zones are what I was talking about with environments. So zones are areas in which individuals can access the data. So, for example, developers have access to the test zone, whereas clients would have access to the production zone.
So
Does that answer your question? I want to make sure that that was what you were asking.
I'm still a little confused on the physical. I'm trying to relate them back to the three examples you provided. So you said that the physical and logical piece of it build into the Star, Snowflake, and Galaxy. I'm trying to connect it to the two concepts.
Yeah, so the Star, Snowflake, or Galaxy is kind of a design choice on how to lay out your database. Whereas from the sounds of it, the physical and logical data layers would be the actual data that lives within any of those databases.
Okay. Maybe I just need to let it marinate a little bit longer.
Okay. I am on the Syracuse IO Slack channel as Amanda Darcangelo, so if you would like to reach out, feel free to. Also, as I mentioned earlier, I am now putting my email address in the chat. So feel free to reach out to me with any questions that you come up with, over the next couple of days. Thank you so much, Kyle. Yes, the pictures will help. Yeah.
I don't know if that's a particularly good one. It's just the first one I found because I wanted to look at it myself as well. So yeah.
Yes, these are great. Any other questions?
Question. I did join a little bit later, so I didn't hear I just joined this from Meetup because I saw it and it looked really great. I didn't hear the purpose of the calls in the series.
Yeah, so the welcome. We are Syracuse's chapter of Women in Machine Learning and Data Science with a goal of furthering women and non-binary in a very male-dominated industry. So we do a lot of speaker sessions that give insight into different types of careers that are available within data. We often put out job postings that are available, and we do trainings like this. And so the goal of this training arc is to give a baseline of the wide world of data. So these trainings will be broken out into a couple of different segments. Each segment will be perioded by a discussion session on that segment. So for example, this segment that we started tonight will be on high-level data theory. And then we will have a discussion session. The next segment will be coding. So we'll work through Python, Excel, SQL, R, maybe a few other things thrown in there. And then we'll have a discussion session. And then we will do a segment on the usage of data within industry. So we'll look at different career paths and different industries that use data.
Okay, thank you.
Okay, I know we're a little over time and everyone is probably ready to go on a Thursday at 8 o'clock. But just a couple of announcements before we wrap up. Just to repeat what I said at the top of the session, we will be focusing or announcing in a few months. So at the start of the year, we'll be looking into doing project sessions, allowing a space for people to work together, to develop different teams and create projects. More details to come, maybe a little bit of a pitch competition or something like that. But that will be down the line. So as we go through the trainings, just keep that in mind if you're interested and want to think of different projects. The second announcement I have is if anyone is interested, I did hear about an AWS-based team lead position. So Amazon Web Services, it would be a data engineering position. If you are interested, please reach out to me at the email address I provided, and I can give you more details about it. Otherwise, thank you all for coming. This was one of the bigger groups that we've had. It was really exciting, and I hope you all liked it. Feel free to send any feedback, and I hope to see you at our next session.
Thanks,
Thank
everyone.
you.
Have a good evening.